So take it away, Klee.
Yeah.
Okay. All right. So, scientific clues that we are living in the Matrix. That's my little plug for my favorite movie of all time. A self-organizing program, as opposed to a program that was programmed by some programmers. So reality might be pixelated at the level of space and time itself. Heisenberg believed that as a particle moved a very small distance between points A and B, that it teleports or jumps without covering the space in between. But Schrödinger believed that in most cases, the particle moved classically, smoothly from point A to B, traversing an infinite number of points in between. Heisenberg was furious about this because he's the one who started this. It was Schrödinger who came in after him, and Heisenberg was planning to create a whole revolution in thinking, a new paradigm that once and for all leaves the ancient notion of smooth space-time and moves us into the digital age. Which was ironic because there wasn't a digital age at that time. This was 100 years ago. So he was ahead of his time. So he insisted that the evidence which he's developed clearly pointed to the fact that there were only jumps, that's it, and that we need to boldly move away from the ancient notion of smooth motion. Schrödinger did not argue that there was evidence for smooth motion. He admitted that there is no evidence for smooth motion. But he said it sounds unrealistic. Can you blame him? If you don't see the Matrix and you don't have an iPhone and you lived 100 years ago and there's literally horses and carriages outside of your office, it would sound crazy. What do you mean a digital pixelated reality? What does pixelated even mean? Nobody had a monitor back then. So what Schrödinger said was, if we are still going to put up with these damned quantum jumps, I am sorry that I ever had anything to do with quantum theory. And in fact, the vast majority of the titans of the scientific community of this turn of the century era agreed with Schrödinger that, evidence or not, it is far too radical and aggressive to imagine that reality is pixelated in the way that Heisenberg was arguing for. What happened is Schrödinger's view prevailed. Ironically, Heisenberg's view was more logical, and Schrödinger added ad hoc this idea that there is smooth motion. So all the evidence showed that a particle is here and then it is here. And so Heisenberg said, let's deal with that, the data that we know. And it's a new paradigm. And then Schrödinger said, come on, that's just not even realistic. What is it? That's magic. And so we should imagine that even though we have no evidence of it, the particle is smoothly traversing. And so because of these old guys deciding this, I mean, they were old at the time. So they were in an old era, and they were old at the time. So today, 100 years later, we have the majority of scientists still believing, confusingly, in a reality where somehow pixelated jumps of an electron between two atomic orbits can exist. They admit to that. But yet, in other situations, an electron just smoothly moves in the old classical way, again, traversing a literal infinity of points between. So what was happening 100 years ago, in my opinion, is that nature was whispering in our ears of the scientists at that time. She said, I am smooth. I am pixelated at the Planck scale, which is the smallest pixelated scale of reality. I am pixelated both in time and in space. We understand what that means because we have video monitors. Imagine these guys 100 years ago. If nature was saying that to them, they'd be like, I'm sorry, I don't understand. What are you talking about? Right? It was weird to them. It's weird to us, but it was way more weird to them. So that was a hard pill for us to swallow at that time, right, as a species. So we invented this ad hoc compromise, which was to artificially assume smooth motion regardless of the evidence. So why does mathematics explain the universe? So the first section was to say, hey, we may be in a pixelated reality. That's one clue that we're living in the Matrix. Another clue that we're living in the Matrix is the fact that mathematics, as noted by so many scientists, it's just unreasonably beautiful. The equations themselves, the mathematical beauty of the universe is overwhelming to many scientists who understand it enough to appreciate it. Everything relates to E8. So I can make E8 seem simple to you guys. E8 is a fundamental crystal. It's a fundamental lattice. In 2 dimensions, one of the fundamental lattices is the checkerboard. And in 3 dimensions, one of the fundamental lattices is the way that oranges are stacked in the supermarket. If you go into an 8-dimensional supermarket, the way that 8-dimensional oranges are stacked in that 8-dimensional supermarket is called the E8 lattice. And what's so special about that way of stacking 8-dimensional oranges? Well, you can't get any denser. In fact, the way we stack oranges in the supermarket has been proven to be the limit. You cannot make spheres in 3D any denser than that packing of the way they do it with oranges in the supermarket. So it's very special. There's an infinity of ways to pack spheres, but that one and only way is the densest way. Well, that in the BCC, which is sort of a twist of that. But so that's what the E8 lattice is. And what is it made out of? It sounds like it's complicated, right? Because it's 8-dimensional. But it's actually not complicated. The entire E8 lattice is made of equilateral triangles. So that if I gave Jeff a stack of a few hundred equilateral triangles, and he was allowed to rotate each equilateral triangle from the other ones by just some angle, which is arc cosine 1/3, which is about 72 degrees, as long as he's allowed to rotate the 72 degrees into the 3rd dimension, right, and then again that next one into another dimension away from that and away from that, he can build the whole E8 lattice with just equilateral triangles and one rotation, or with tetrahedra and one rotation. So the E8 lattice, like all lattices, is composed of a fundamental shape. So just like the checkerboard is composed of the square, and the way we stack oranges in the supermarket is composed of a fundamental shape called the cube octahedron, so too the E8 crystal is composed of a fundamental cell or shape, which is called the Gaussian polytope. And it's very beautiful, and it's made all of equilateral triangles and tetrahedra, or tetrahedra, however you want to look at it. And why am I talking about this E8 polytope, this E8 shape? Well, interestingly enough, all particles and forces are variant shadows of the vertex relationships in this one shape. You can think of it like a higher dimensional Platonic solid, right? So in each dimension we have a higher dimensional square, like you have a 4-dimensional cube called the tesseract, and it keeps going. So you can think of these simple shapes in E8 in 8 dimensions as just higher dimensional sacred geometry, higher dimensional polytopes. And so you don't have to be a particle physicist to understand that everything in reality that's fundamental can be converted into everything else. So what's fundamental? Well, you've heard all the words. Electrons are fundamental, quarks are fundamental, photons are fundamental. There's a few other ones, like neutrinos, that are fundamental. And then we have gravity. That's fundamental, and just conceptually we imagine gravity as represented in a pixelated manner by an idea called a graviton, which is just a way to think about the quantizing of it. Well, all these fundamental things, if we were to write them out on the floor, we would see, gosh, so all of the complexity of reality is only made of a few things. And what can we say about these few things? So to me, the most fascinating thing that we can say about them is they are all convertible into all the others. It's called a gauge symmetry transformation. It's kind of like, in fact, it's not kind of like, it's mathematically exactly like this. My hand is not going to change because I'm making it rigid. But this shadow on the wall here is not my hand. Mathematically and in every other way, it's a different object than my hand. But it's deeply related to my hand. My hand lives in 3D, and this shadow on the wall lives in 2D. And there's another shadow, this one. Okay? This one is also deeply related to my hand. And because both of the two shadows are related to my hand, they can be converted into one another by a simple rotation, a specific rotation. And so these particles and forces, like photons and electrons, they get converted into one another by particle physicists mathematically with something called a gauge symmetry transformation, which honestly is not that much different than the rotation that you translate to get this shadow into this shadow. So you can call my hand the invariant object because it doesn't change. And you can call the shadows the variant objects. So everything that we know of in reality, which is this small list of a few things, which includes gravity, are variant shadows. They get transformed into the others. If you realize that, it should make you sort of think, well, holy crap, what is the invariant thing? Right? Because we're told that those are fundamental particles, but they're fundamental for a reason, not because they can't be converted into another one. They're fundamental because we believe that you can't break them apart and get another particle that builds them. But they're not fundamental in terms of being the invariant thing. So this is not my theory or my idea. This has been known since the 1970s that the E8 polytope is the only invariant object that unifies everything that we have in our reality. That is, the fundamental things. Because we can know how the mating behavior of dogs and notions of complex societal behaviors all come from these ultra-simple things. But the ultra-simple things are all mapped to the vertexes of this E8 polytope. To me, that's the most exciting fact that the general public doesn't know, but which is not disagreed on among scientists. It has been known since the 1970s. The original string theory in the 1970s used 2 copies of E8 because it's the only object that unifies all the fundamental particles and forces, including gravity. So the pigeons are just meant to say that if all those pigeons are the same pigeon, there's several different shadows, and the shadows are the invariant particles, of the variance particles, and the bird, or the one bird, is the invariant E8 polytope. Okay, so why is this idea of smoothness so hard to shake? I'm just going to give my humble opinion. I think it's common sense, because ever since I was a little kid, playing with my mobile, that's me. No, that's not me. I just got the idea that there's things suspended in nothingness. Of course, the air seemed to me like nothingness. So to my little young common sense, it was like, I got it. There's a bunch of things like mommy and bottles and the things in my mobile, and then between them, there's just pure nothingness. It's really smooth. I get it. So besides common sense, there's some ancient creation myths where an old dude from outside the system, or one of the Greek pantheon gods, or somebody from outside the system, decides to bestow creation upon some void of nothingness and make some stuff, like the Greeks' indivisible atoms. Okay, the Greeks believed that those atoms were made by someone and that they were separate, as though the completely separate universes. The dude who makes stuff, and then the lucky people that are the objects within that stuff that gets made. A deep separateness. So before the guy makes the stuff, what was there in this myth? Pure nothingness. Smooth, homogeneous nothingness. And then there's stuff, the somethingness. So it's not only common sense, but it comes deeply from our language, our cultures, all the way back to the ancients. I mean, even now, today, to modern Christians who would believe that there was a nothingness and then a God created a somethingness. So our group converts the E8 lattice into a logical three-dimensional representation. And so we can call this three-dimensional point space the possibility point space. So it's not physical yet. It's this mathematical grid at Planck scale that has an aperiodic structure. That is, it's not periodic like a checkerboard. It's aperiodic, otherwise generally known as quasi-crystalline. And and the fundamental lengths in this structure that's derived from E8 are 1 and the golden ratio. We don't do anything ad hoc. Everything that we do comes from geometric first principles. And when you project E8, you just get these golden ratio structures. It's just what happens when you project it along one of its fundamental axes of symmetry. So remarkably, there's images like this that are out there to be researched. The relationship between the Earth and the Moon is defined by 1 and the golden ratio. That is, the distance from the center of the Earth to the perimeter of the Earth, plus the distance of the perimeter of the Moon to the center of the Moon, forms part of a triangle, and then again the same distance, the distance from the center to the perimeter. I'm talking about the core of the Earth, the gravitational center of the Earth, to the perimeter. Then that's the other length in the triangle. And then drawing this line up back to the centroid of the Moon, you get this triangle. And you might say, well, I've never heard of that. That sounds like it's the news of the century. Does everybody know that? Is that controversial? In fact, no, it's not controversial. You can go to Wikipedia tonight, get the numbers yourself, and you'll see that it forms this to 99.975% accuracy, virtually 100%. And this is not an anomaly. There's over 30 such unbelievable and frankly incontrovertible. They're just because they're just data points. They're empirical data points. There's about 30 or so of these ridiculously unlikely coincidences in our solar system relating to the golden ratio that have been published by other scientists. But the problem is Einstein's theory of gravity doesn't predict this, which in another way of saying it is it doesn't allow this. So you'd have to say that all these 30 things are just mere coincidence because Einstein's gravity theory doesn't allow it. Einstein's gravity theory supposes ancient smoothness. It does not predict any substructure to space-time like we do, and other groups do as well. There's a lot of university groups working on theories of gravity that are more modern than Einstein's that suppose substructure at the Planck scale. So what we do then is we do binary selections of points to be on or off in this possibility point space. So it's a binary language that's defined by quasi-crystalline rules, which are geometric first principles rules. And so different configurations on that possibility space give you quasi-crystal patterns that look like this. So picture each of these tetrahedra as a three-dimensional pixel of reality at the Planck scale, which would be about your height divided by 10, divided by 10, divided by 10, 34 times. So that's the Planck length. In fact, the Planck length, coincidentally, is about as far away from you as you are to the diameter of the universe. So funnily enough, humans in the sweet spot of all this good stuff like DNA, like it's not just our perspective. All of the interesting stuff happens right about in the middle of a 64-0 universe. The most complex molecule, the most known, is DNA. The most complex neural network is the human brain. The most complex system that we know of is the biosphere of Earth. So all of these things are happening approximately around the center of a 64-0 finite universe. So picture each of these then as the pixels on a screen. That's one frame of a screen. It's not moving yet. There's no motion. There's just little pixels. Those are the pixels. Then consider that I make another binary selection on the possibility point space, and I create another set of pixels that's different, but that follows the rules, and I call that frame 2. So then you kind of imagine reality then being in this story of a sequence of these frozen frames, frozen 3D frames. So in the movie Gone with the Wind, there is no time or motion. That's all illusionary. There is only an ordered sequence of two-dimensional geometric frames. So what are some of the general things that we can say about this construct that we live in? Okay, we don't have to know for sure what it is because we're just theorizing here. But we can say some things about it. We can say that evolution seems to occur in the universe because we watch stellar clouds of dust in star nurseries self-organizing or evolving into much more complex spiral galaxies. We see biospheres wherever they get going. Like here, we see runaway complexity because as each species opens up new niches, and so then there's more niches in the second round than there was in the first round. And so new niches open up from the third round, the fourth. And so if you leave a biosphere unattacked, and you don't destroy it with nuclear war or asteroids, any biosphere will tend towards infinite complexity. It doesn't. There's no known stopping point. Niches upon niches upon niches, which is why today we have 10 million species on this planet. And in the history of the 4 billion years of life, we've had another 90 million species. That's 100 million different species in the 4 billion years that life has been going on here. The other thing is emergence. All that emergence means is that in a given system, it starts running away towards emergent complexity. Here's an example. We're told in high school that all of physical reality, as far as matter, is made of quarks and electrons. That's it. Quarks and electrons. Two things. And then that self-organizes to the next layer of things, which is 81 stable chemical elements. And then that self-organizes into countless numbers of chemical compounds. And then that self-organizes into biological compounds like proteins. And then that self-organizes into very primitive single-celled things. And then billions of single-celled things self-organize into Jeffness, right? That float, Jeffness, which somehow floats on an ocean of these simpler things that don't know about him as much as he knows about them. Like I would say that Jeff knows more about the red blood cells, the living little guys floating in his blood, than they know about him, although they're both interactive and co-creating one another. That's emergence. Self-organization. Everything self-organizes. Crystals, weather systems, the biosphere, our solar system. Things self-organize. These are behaviors of the universe that are universal. And feedback. Every system is in feedback with every other system via sound, via magnetism, via electric fields, and via gravitational fields. There is not one system that is not in some sort of dissonant or resonant relationship with every other system in the entire universe. And so feedback is a deep fundamental principle. And by the way, that is partly how things self-organize, emerge, and have evolution, is they feed on feedback. Feedback helps with something called the principle of least action and conservation of energy. So, evolution, emergence, self-organization, these are starlings. So, it's very beautiful, these massive flocks of starlings, they just start self-organizing into these non-chaotic patterns, and it's hard to understand. I mean, people have done papers on it, but how they do that, it's just fascinating. And feedback loops. So I got a new agey picture here to represent feedback loops where everything is in some sort of feedback loop with everything else. But what else can we say about reality besides those four things? Well, we can say that consciousness is part of reality. And we can say that it emerges, right? I mean, there's no materialist scientist who denies that he's conscious. Actually, there are. Me and Jeff know that there are some, but it's a small minority of hardcore materialist scientists who would actually go so far as to say that they are not conscious, that they are like a robot or a zombie. And so even they would admit, fine, consciousness somehow is part of the stuff of reality. It's part of what physics does by the processes of emergence, self-organization, feedback loops, and evolution. But what defines consciousness? That's a big slippery slope. What is it, though? So these are my twin poodles. I just took the picture this afternoon. That's Ted and Red. And Ted and Red happen to rank number 1 or number 2 on the most, there's like a bunch of kennel associations in this country and in Europe. And they rank dogs according to intelligence. And how they measure the intelligence, I'm not quite sure. But they rank them. And these poodles, either on various lists, always rank at either number 1 or number 2. Standard poodles, not the toy poodles. These big ones are smart. I mean, these guys make eye contact with me, and they're just like, dude, what do you need? I'm here for you. But are they conscious, though? because they're super intelligent, they rank number 1 or 2, so are they conscious? They kind of seem that way. They got something going on in there when I look in their eyes. And they have a lot of emotions, these 2 dogs. So this is Susie. She's also my dog. Unfortunately, she ranks number 87 on the dog intelligent list. It would be okay if there were 500 dogs on these lists, but there are only 100 dogs on these lists. So Susie made she made the list, But we bred the intelligence out of her to turn her into a purse dog. Not me and my family. We bought her that way, but the breeders did that. But we love her anyway. So, and by the way, I'm really glad she's not here tonight because I just really talked bad about her.
She would be dissed.
But I must be honest, she doesn't seem to me as conscious as Red and Ted. So I'm willing to admit that they kind of seem conscious. Like, I don't think they're as conscious as me because I know I'm smarter than them. And I think smartness has something to do with consciousness. And so I think they're more conscious than Susie. But what about a mouse? Because scientists tell us Susie is smarter than a mouse. Right? The animal scientists, they kind of rank animals. They say dolphins are smarter than ants. Right? We don't have to agree that all animals are equal intelligence. So Susie gets to be smarter than the mouse. That's what they say. So does that mean the mouse is less conscious than Susie? If we're generous enough to say that most of these living mammals get to be conscious, they're just different gradients of consciousness that somehow map in some way to awareness, which maps to intelligence, right? That there's some correspondence. But do you think I'm being cruel with my arbitrary labeling of intelligence and consciousness? Or should I, say that everything living is conscious and there's no need to label gradients or hierarchies? So, but I'm going to do it anyway. What about my salad? Is my salad conscious? For sure my salad is living until I cook it in the microwave. But before I cook my salad, it's still living. The cells are living. They can still reproduce in a petri dish. But do I have conscious salad? My mom had a boyfriend once who would not eat salad with a fork because he believed it caused the salad pain. Wow.
How did he eat it?
With a spoon or with his hand?
I mean, his teeth.
Oh yeah, but that wasn't logically consistent. But there was just something about stabbing it with the fork that somehow the crushing of the teeth was okay. So that salad is living, right? So maybe we make an arbitrary cutoff, right? Because we're being cruel here with our labeling. So we can say the salad is not conscious, but it is living. It's definitely living. In fact, every one of the cells of this salad has DNA. And so we say the salad is not conscious, but it is living. And Susie, even though she ranks number 87, is conscious, and she's living. So these labels are starting to feel non-scientific to me. They're kind of feeling man-made, a bit arbitrary. But I do believe there's hierarchies, because I do believe that Susie is more intelligent than my salad. But just the cutoff point.
Certainly not going to put a fork in there.
Yeah, no. But it's the cutoff point that I want to challenge you to find interesting, because it's the cutoff point of what we get to say is living matter. All the matter is self-organized. There's very little matter that has no form of organization. So each of the living cells of the lettuce has DNA, and that DNA happens to be about approximately as complex as the DNA of the mouse, or my DNA. In a petri dish, the cells run from harmful substances, the cells of the salad, that is, and the cells of my body. They both run from harmful substances, they chase nutrients, and they reproduce, and they excrete waste. So what is this lettuce cell? That's not a lettuce cell. What does a lettuce cell and all the other single-celled organisms, this is a single-celled organism, so what do they have in common with us humans, us big colonies? We're just colonies of billions of single-celled organisms where we have emergent Jeffness, right? What do we all have in common? Well, we have in common the tendency to survive and propagate our patterns. We want to survive and we want to propagate our pattern. We also have these things in common: evolution, emergence, self-organization, and feedback loops. This whole thing is a wobbling bowl of Jell-O. Every part of it, every atom within it, is conserving energy through the well-established process of feedback loops. But what else? What else do we have in common with these little guys? Unpredictability. You cannot predict where one of these things is going to move next. You can apply some statistical probabilities, and you can sort of narrow your odds, but you can never predict it, and you can never predict a human. Now, we kind of know why you can't predict a human's behavior with absolute accuracy, because we believe humans have free will, and so that's our answer. You can't predict how a human is going to behave or where he's going to be tomorrow at 2:35 p.m. because he could change his mind. He's got free will. Same thing with these guys. But usually when it gets to stupider things like those and things that we label as not living, we say, well, we can't predict that because we believe in the theory of randomness, not free will. So with us, it gets to be free will. That's why you can't predict us. With other things, if they're lucky enough, like my poodles, to be bestowed with the label of consciousness, I might say they have free will, which is why I can't predict their behavior exactly. But I might say that the pattern of a quartz crystal growing in a cave, I can't predict exactly its growth pattern because of the theory of pure randomness. I absolutely refuse to believe in the atoms at that scale having any sort of consciousness or free will or any analog or approximation of that. Not me. I'm saying if I were speaking for the materialist scientists. So all these living things are just self-organized electrons and quarks, right? Like, we're self-organized electrons and quarks. This is self-organized electrons and quarks, and so is Susie. Now, what about a virus? See, a bacteria is similarly complex to the cells that make up me. A bacteria has DNA, and it has all those parts, similar to the parts that I showed you. But a virus is orders of magnitude smaller, way, 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 way smaller than a bacteria, and way stupider, simpler. Doesn't have all the good parts. Doesn't have DNA. Does it? It's more like just a glob of just atoms. It doesn't seem living when you study it. It is fantastically smaller and more simpler. And in fact, a lot of the guys who got to label what is and is not living decades ago, they were arguing about viruses. And today, many biologists think that viruses should never have made the cut. In fact, they argue that viruses are not living. There's entire books about it, academic books. But some other dudes, unfortunately, they are mostly guys. They get to make these rules in the history of science. They argue that we should go a little lower, that we should include viruses and even go lower than viruses, and that we should label crystals as living forms of self-organized matter. The reason is because they were serious in their arguments, and they say that crystals take resources from the environment to perpetuate their organized pattern. And that DNA should not be this arbitrary distinguisher between whether something is living, organized, self-organized matter or not. So I can see both points of view, okay? But I can also see that it's just arbitrary. It's just humans putting these labels on self-organized systems where all these self-organized systems seem to show a propensity to propagate their patterns. In fact, these patterns will keep propagating. If you don't mess with them, these crystals, some of them will just keep growing and growing and growing. I mean, they'll get even bigger than this. They just keep taking resources.
Is that a real person in there?
Yeah, that's the scale. So these are these caves in Latin America where these massive crystals are allowed to form over many millions of years. So we talked about crystals. I'm trying to draw controversy out here and to get you to question. Well, maybe a virus isn't living, or maybe a crystal is living. Maybe Susie is conscious, right? Okay, what about the self-organizing behavior of a tornado? It's pulling up resources from the ocean and from the air, and it's using feedback systems with its environment and feedback systems within its own structure, and it needs to keep its pattern. If it's lucky, it can be upgraded. Like these hurricanes, if they're really good at what they're doing and their feedback systems are gentle enough to upregulate their taking resources from the environment, you can get a level 1 hurricane to get up to a level 5. That's a lucky self-organizing pattern. So it seeks to perpetuate its pattern for as long as possible. it has the hallmarks of self-organized matter that attempts to exist for as long as possible. And it does that with the feedback loops of the environment. So the point is that the simplest objects of reality do seek to self-organize and perpetuate their patterns, whether they get to be labeled with the blessing of DNA and our labeling systems of life or not. And they do this, all of the systems, from humans to the tornadoes, they do this in a way that is unpredictable. We can only approximately predict their behavior statistically. And they do it by being resonant or dissonant with everything else in the universe, literally everything else. All right, so yes, some of these self-organizing systems are more complex than others, like Red and Ted. But in terms of the basic tendency to perpetuate pattern and survive and self-organize and be in vibratory connection with all the other systems of the universe, there really is no difference. So a more modern labeling system is probably in order, I think. So we challenged our assumptions about what life is. I mean, I'm not trying to define it. I'm trying to just shape labels is all that I'm doing. So we challenged assumptions about what life is and what the cutoff should be. And we challenged, what should define consciousness. Because where do I cut it off? Red and Ted or Susie or my salad or single-celled organism, viruses, should they make the cut, should they not? I'm willing to just say that all this self-organizing stuff that seems to show a desire, a propensity to perpetuate its pattern by self-organizing and entering into feedback loops, it's all kind of lifelike. So the final thing is to challenge whether reality is made of information or some other stuff. So I think reality is made of consciousness and information, but let's first just play along and say it's made of information, because a lot of scientists now think it's made of information, literally. It's becoming a popular view. So the pat answer is that since matter equals energy according to E equals mc squared, then everything is made of energy. So you ask some guy at a university, what's everything made out of? And he'll say, well, everything's made of energy. And even matter is made of energy. And say, okay, so everything's made of energy. All right. But that's too easy. I think so, because I don't know what energy is. What is it? So we don't have time to really break it down, but I can tell you that energy is information. This is a well-established scientific deduction that is known, even though not all scientists agree. John Wheeler, who coined the term black hole, was one of the first titans of physics to argue that reality was made of information and nothing else. Today, thousands of scientists, such as mathematical physics professor Max Tegmark at MIT, argue logically and write books and papers that reality is information. So interestingly, those who disagree that reality is made of information actually are not able to come up with an alternate definition of energy as anything other than information, because the classic definition implies that it's information. They just say that my position is that reality is not made of information. And I know, because I've challenged many of them, and there is no answer to that. So the scientists, realizing, though, that reality is information, are able to define what information is. I'm going to try to define it, and it's not a big mystery what information is. Information happens to be meaning conveyed by symbolism, symbolic languages. That's a known definition of information. So then what is a symbol? Well, a symbol is something which represents itself or something else. For example, an equilateral triangle can represent itself. I can use this as a symbol to represent the equilateral triangle, or it could represent something else, like the delta symbol for change. So then what's language, right? Because we're saying information is just meaning conveyed by symbolism through language. Then what is language? So all quasicrystals, including our E8-derived quasicrystal, are languages. So what is a language? And by the way, geometric languages are good at expressing geometric meaning. So from the waveform of a photon to planets to poodles, everything in reality is composed of something geometric. Even something as emergent and abstract as love can be traced back to its geometric building blocks. So what is going on here? If reality is geometric language, and if this language is just information, then where does all this information come from? So information can only come from mind. This is not a New Age notion. Information is the product of measurements. And it requires an entity to choose to do the measurement. And information is meaning. It is meaning conveyed by symbolism and generated by measurement. So meaning is subjective, right? All meaning is always subjective, and therefore it requires an interpreter to ascribe meaning to it. So the very textbook definition of information cannot be ever disassociated from choosers of measurement and users of the language that expresses the information and the subjective meaning of the information. Again, this is not novel. This is standard stuff of what information is. Okay, so but how? How does all this stuff in the universe, how does all this information come to be? So how can an information-only universe exist without the universe itself being a mind-like substrate? So most of you here obviously would be content to agree with me that there is a universal mind of some form, of some type, even if we don't understand it. But the fun question, though, to me, is always the questions of the 8-year-old child. Why? Where? How? You just never stop until you're satisfied. So where did this universal consciousness come from? So we discussed how consciousness is known by materialist scientists to be real and to exist in the universe, since they think they are conscious. And it is known that when an organism has no limit on its resources, that it will continue doubling. For example, a few million bacteria on the surface of this apple are not very influential to the apple's destiny. There are too few of them, just a couple million, because the real things that are influencing the apple's destiny are, the intermolecular forces and gravity and a whole lot of other things, the tensile strength, the bacteria are nothing. They're inconsequential. But after just a few rounds of doubling, the bacteria actually switch roles to become the overwhelming defining force that determines the very destiny of the apple, returning all of its elements back to the biosphere. It becomes stronger than the intermolecular forces or gravity. So I can hit the times 2 button on my calculator 80 times in 30 seconds. I thought about that. How fast could I do 80 times doubling? Double. I can do it in 30 seconds. And if we doubled a penny only 80 times, we would have more pennies than all the atoms in all of the galaxies of the entire universe times billions. Doesn't seem right, does it? And that's because there's nothing in your world that's trained in the hardwiring of your mind to think of doubling algorithms. Doubling is a freaky thing. And there's nothing that you see that ever really does that. It happens with bacteria at a very small scale, but what happens is they rapidly, after only a few doubling cycles, they use up their resources, and then they stop doubling. So it's very rare that we get to see a doubling algorithm come remotely close to the 80 times. And in our macro scale, things accelerate in linear ways. Cars accelerate linear. The lions on the African savanna would accelerate and chase us in linear ways. Things get faster, but linear. Doubling is a weird thing. So, if human consciousness could escape the limitations of Earth and just keep doubling, right? We can't do that here. We can't keep doubling. But if we could escape the limitations of Earth, we would be able to double within a shockingly small number of doublings. There would be more conscious entities in the universe than all of the planets times some huge number with dozens of zeros. So we started leaving the planet in 1968. And right now we're just bursting with desire. I'm a major shareholder in a company here called Moon Express at Moffett Field. And we're now part of the new generation of private companies that are now leaving the planet to do things. It's not in the hands of government anymore. It went too slow. This is going to happen. Most everything that you see in science fiction movies happens. Remember the flip phone from the old Gene Roddenberry Star Trek? Remember when those flip phones first came out? It's like, oh my God, Gene Roddenberry, he's a futurist, a genius. He predicted the flip phone, and I have one in my pocket. And now, if you have a flip phone, it's like you're a loser. You're like so past. That's like 12 years ago, right? We have these now.
They have tricorders now when they check out your temperature. Or
Yes.
they do a tricorder team.
Yes.
Just at the
Another company that I'm involved with that's at Moffett Field also is called Scanadu, and we're producing a tricorder, and we're competing to make the tricorder. So, but anyway, so I'm going to keep pushing because I'm not too far from the end. So we're bursting with desire to do this, which we've all seen in the science fiction drawings. Is there anything in physics or anything with the relentless exponential doubling of technology? I mean, I have the ENIAC computer was millions of times weaker than this, and it weighed tons. So this is going to happen. We are leaving the planet. We're as good as gone. We'll still stay here, but we will speciate, and we will go out, and we will not be us anymore, because we will speciate, and we will double, and the numbers will not be limited by resources, and so that 80 times on my calculator, the times 2 button, it will happen, and in some finite, really small amount of time, not astrophysical lengths of time, there will be consciousness spreading out throughout the universe. Right now, exponential doubling of technology is actually manifesting our ability to leave the planet in extraordinary ways. I mean, most of us here are old enough to get a feel for the accelerating nature of this weird doubling process, where computer processing is doubling. We're about to come into the era of quantum computation. Weird stuff is about to happen in your lifetime, like Star Trek technology. Gene Roddenberry was wrong. Star Trek is set in like the year 2300, right? That's not going to be the case. We're going to have technologies like that and beyond, probably in our lifetimes. So imagine if high consciousness beings were able to group their consciousness, like parallel cluster computing, right? Right? Like me and Jeff, we go into the Vulcan mind meld together, and we collaborate our consciousness through some psychic technology, or some physical non-psychic technology, neurobiological technology, and somehow the collective combination of our minds is different, enhanced beyond what individuals, and then we go back to being separate. So imagine if we could do that in large numbers, no matter how far we're separated. But what if some new physics that allowed for instant non-local information exchange came on the scene, like a new theory of everything, that allowed us to do real-time, instant-time neural networking? By the way, this is the universe. This is a scientific depiction of the tentacles of energy that connect in filaments between galaxies. This is such large scale. Each one of these nodes are galaxies, and this is a brain cell. So the universe has the topology of a neural network. So that sort of neural network is generally called what I just described. If humans go out and we're like all over the universe, and then we develop some new technology that allows us to connect instantly, then what we are technically is called a neural network. That's just any network of things, objects, which have high connectivity between them and exchange information, and also create new information as products of the exchange combinations. Simple. Many things are neural networks. So the universe as a whole is an exchange network because everything is connected by gravity and electromagnetism. Nothing whatsoever is isolated. And popular astrophysical models of the early universe say that shortly after the Big Bang, the universe was a hot soup of particles called a Bose Einstein condensate. Now, this is actually the most popular view, that there was a phase which was a Bose Einstein condensate. And so when two or more particles are in a Bose Einstein condensate, you can then, after that, separate them, and they can remain quantum entangled. So this was a prediction of quantum mechanics decades ago, and only very recently did we have the technology to experimentally confirm it, and it was gloriously confirmed. It's just weird. It's like basically, it means like if you have if you have one particle that used to be in a Bose Einstein condensate, and then the other particles that it was with, if you have two of them, let's say, and you separate them, like one on Alpha Centauri, 4 light years away, or one in another, literally another time, right, another region of space-time, and then you flip this particle, it will instantly flip the particle. Not at the speed of light, not faster than the speed of light, at no speed. It's like if I have a quarter, and I'm looking at the head side, and I grab the little head, and I turn it, or I just turn it. You don't really ask, well, how long did it take for that side to communicate the message to the other side that it was turning? It's sort of like a false question. You say, well, no, you're turning the whole thing, right? Similarly, these particles, even though there's this notion of separation, they're one. They are quantum entangled. So so the particles can be separated, like I said, by light years, and they're connected. Quantum entanglement. So all the particles are likely now to be quantum entangled. The early universe was much smaller. There was this one phase where the mathematics shows us, astrophysicists that is, that they were all in a Bose Einstein condensate, and then they keep going out and they get separated in space and time, and they go on to form humans and form planets and far-flung galaxies, and they remain entangled in an instantaneous, zero-time neural network. So those are just two logical ways. If you've caught what I've said, I'm trying to say how emergent collective universal consciousness can exist. I am not saying it is like our consciousness. It is not like the old man with the beard. I am saying that the whole universe, if it has the topology of a neural network in instant time, because everything was a Bose Einstein condensate, there is one plausible, could be wrong, but it's a plausible logical framework to say, well, once you have the topology for a neural network, can emergent pathways of complexity emerge? Because, that's what happens in a brain and other neural networks. We actually make artificial neural networks now. So perhaps, right? We can just say, maybe, right? And and then the other conjecture is, well, wait a minute, if humans do have the ability to double, and if some new physics allows us to sort of teleport to other areas of the universe, then how are we going to populate the universe? In other words, if we don't discover new physics that allows us to go non-locally to another location, then the way that we're going to populate the universe at the very maximum is at the speed of light, ballistically, like a ballistic trajectory going out from Earth in all directions, our descendants, out. But the problem is the universe itself is expanding at the speed of light, and so we would never be able to permeate the entire universe with our consciousness and our descendants' consciousness. But what if we could go out and simply choose coordinates, and through some new physics go to these coordinates, right? Teleport to these different coordinates, right? Be some physics or technology that doesn't exist. Well, then you're going to have no limitation of resources, so then humans are going to do the doubling 80 times, and you're going to get to just unfathomable numbers of conscious beings that actually more spread out to every location in the universe sparsely, like a sponge. A sponge is mostly empty space, but it has the topology of sort of being on average that low density everywhere. So if that technology emerges, we and our descendants will go out and we'll populate the entire universe, and it'll be really sparse. They'll be separated by great regions where there's no consciousness. And then because of the doubling algorithm, which is, again, freaky math, it just is what it is, we will rapidly, in non-astrological time frames, in human society time frames, we will fill in the density of the sponge, as though you visualize a sponge of consciousness distribution in the universe, then densifying with exponential doubling until it's completely filled in. And that's why I showed you the analogy of the bacteria on the apple. At some point, the materialists would laugh and say, it's just humans, like the Romulans and the humans in Star Trek, and they're all over the universe, and they're teleporting about, but they're still not a force to be reckoned with. They're not like gravity. They're not like some real force of nature. But what happens is at some scale, like the bacteria, they become the dominant force that defines the destiny of the physical system of the universe. So, what does that mean? What came first? The emergent consciousness that I'm describing, or all this physical stuff, right? Because it sounds like a chicken or the egg question, doesn't it? What comes first, the emergent consciousness, or all this information relating to E8 and all this mathy geometric stuff, this sterile math stuff? Right? So the E8 story is that this simple code emerges, and then electrons and quarks and humans come out, and all this emergent consciousness and poodles, right? So what comes first? Because I can get how all that stuff could build up to this sponge thing and consciousness, like the bacteria becoming the defining destiny of the universe. I get that, but don't you need the physical stuff before that? And if we're saying the physical stuff is just information, and the information has to exist within a mind-like substrate, some computational substrate of some sort, then what's the deal? Chicken or the egg, right? Well, but if I ask you that question, and I convince you that that's a good question, it shows your hand. It shows that you believe in strict linear causality, which, like most of us tend to believe, I'm living my life with causality, you know. But if linear causality were wrong, if that's just a wrong thing, if it doesn't exist, well then it would, in fact, this whole question that I just posed, what came first, the chicken or the egg? The high consciousness is the consciousness substrate, or this mathematical geometric stuff, what comes first, right? Well, what comes first on the clock, 9 or 3? Well, it's a false question, isn't it? Because the numbers are on a circle, you know. So this little illustration of the Ouroboros is a great visual symbol to represent that if you wrap a causal chain into a circle, you can have logical consistency, where you do not need to ask any longer what comes first. So this stands for grand unification theory. And so it's just this sort of idea that there's this, imagine my tetrahedra again, and my E8 related possibility point space and these binary things, and all my story about language and code and all that. And I'm saying, well, what does that live within if it's just information? It lives within the head of the snake, which is the emergent collective consciousness of the universe. But where did that come from? Is it like the old man creating us? Is it separate, or did we create it? And so it thinks of the primitive math. The primitive math self-organizes because it's geometric math, which means it's expressing through language geometric things. And I've argued that everything about us can be traced back to geometry. And it just keeps going, and it gets up to these levels where it seems transcendent. In other words, at these levels, you can't see its obvious relation to the head, the collective consciousness, the substrate of the universe, the conscious substrate of the universe, because it's so different. So it's like, you know, it's like, how is Jeffness related to quarks and electrons? He seems transcendent of those things, right? So, and it also, in the other direction, from some grand unifying theory, which is the Planck scale, which is way, way, way below quarks and electrons, right? It's this another realm where we can't measure it. So anyway, so that's the famous Ouroboros that's on some of the Theosophical Society literature as an icon, because it has deep meaning. It is the meaning that we didn't create God, and God didn't create us. We co-created one another. Every free will choice that you make adds to the net amount of information in the universe. And the net amount of information of the universe is part of the substrate upon which new, higher orders of information can expand. So every decision you make, so you should be careful. If you're going to be angry that day, go for it, but you're adding that flavor of ice cream to the universe for that day. And it will never be less. It will never go away. The information is not conserved. Energy is conserved, but information is not conserved, because you can keep using old information that's not destroyed to build your new combinatorics of new strata of information.
Wow.